What I'm about to show you is how to do the 3-4-5 method for figuring out the square or how to make a right angle perfect, right? So we're going to be finding the diagonal. It'll make sense when I show you here in a second. So this is the 3-4-5 method, and you're going to use this all the time to check for layouts when you're doing foundation stuff, if you're trying to square up a wall. It's just a quick, easy reference where you can do the math in your head really fast, and you don't have to pull out that calculator. And so 3-4-5 method to determine making something square.
When you're laying out your building, you want it to be square. You don't want it to turn out to be a rectangle. You don't want it to turn out to be some kind of weird diamond shape or rhombus or one of those other shapes. You want it to be nice and square or rectangle. And so we're going to figure out how do we do this. So in the videos, they're doing a major scale, so all the way across the building. So they're going to use the Pythagorean theorem to figure it out. So it's a squared plus b squared equals c squared, and you're going to get that diagonal. Lots of times, you don't necessarily need to do that for different things. There's the 3-4-5 rule, and that is 3, 4, 5. And what that means is when you do the Pythagorean theorem, if it's one side is 3 foot, one side is 4 foot, the diagonal is going to always equal 5 foot. And so, as you see, a squared plus b squared equals c squared, right? So 9 plus 16 equals 25, and so the square root of 25 equals 5, right? You see how that works? And so any multiple of 3, 4, 5 is always going to give you this answer. And so without a calculator, you can know that. So let's just say we'll go one more up. So it's going to be a 6, 8, 10. We multiplied all those by 2, which gives us 6, 8, 10. But guess what? So we got 36. 8 times 8 is 64. Yeah, 64. So you add those together, and that gives you 100. What's the square root of 100? Back to 10. So you can see any multiple of 3, 4, 5, so you can keep going up. So you can do 3, 4, 5, 6, 8, 10. You can do 9, 16, 25. You can do 12, 16, 20. So any multiple of 5 is going to give you an easy diagonal to find. And so remember, this is your triangle. This is A, this is B. So this line is your C. So we're trying to figure out, as you can see, this is a perfect 90 degree. That's what we're trying to make. How do we make this a perfect 90 degree angle? And so the 3, 4, 5 is easy. So what you can do is, once you establish your starting point. So we're going to say, we know this is our wall that we're going to do. You always have to establish what is your base going to be. And so I don't have enough room. We're going to extend this line a little bit to make it 4 foot. All right, so we know from this point to this point, we have 4 feet even. All right, so now the thing is, I want to make a perfect 90 degrees off of this line. Now, I don't know if this line's level, I don't know if it's anything, I just know it's a straight line. So how do I figure out that 90 degree angle? So we're going to use that 3, 4, 5 thing, right? So this is 4 feet, and then we'll say this is side A. So side A is 4. We're going to make this side, side B, we're going to make that 3 feet. You see that? So what's going to happen now, I can put a point here at 3 foot. So I'm going to put this point 3 foot. Now I have a point here. Now I have no idea if I connect those dots if that is a 90 degree corner. If you look, it's actually probably not straight up and down. It looks like I'm leaning to the right. So what you're going to do, this is how you're going to solve or make sure that you get 90 degree corners. So I'm going to hold again my 36 right on my point, and now I'm going to kind of make like an arc. Just rotate back and forth. So now, anywhere on this line is 3 foot from this point. So we know that anywhere on this line is 3 foot. So how are we gonna figure out how to make it a 90 degree? We gotta figure out where are we gonna put the point up here. So what you'll do, you put your end of your tape right on that corner, and then you'll pivot it up, and wherever, right on the corner, wherever 5 foot intersects this line, now you have a 90-degree corner. So all you have to do, let me get a straight edge. Now all you have to do is connect those 2 dots, and you know this is a perfect 90 degree. So that is the 3, 4, 5 method, because this line is 5. And so you could switch this, you could make this one 3, this one 4. I didn't have room to do that, but so this is an easy example. So if you're checking something, you're doing some lines on the floor, and you're putting a wall out, let's say your wall is 25 feet long, you're gonna choose one of these measurements that gets you close. So our wall is gonna say we need it 25 feet long. And then the other wall going the other direction is, we'll say 18 feet, right? So this is our A and B side. Those aren't multiples of 3 or 5, or 3, 4, 5. It doesn't quite work out that way. And to do this in your head, that's hard, right? We gotta try to figure out, those squared, I don't know what 25 and 18 are square off the top of my head. But an easy way to do it is what's gonna be close. So 3, 4, 5, right, is our base. Let's see, what numbers get me close? If I multiply 3 by 4, that gives me, I could do 12, 16, 20. Let's see, 12 and 16 is getting closer. Could I jump up one more? What if I add this? I can go 15, 20, 25. Now there's pretty close. Now can I go even closer? I can go 18, 24, 30. So now these are going to be pretty close, so I can stretch my lines out, and instead of, I'm going to check 18, 24, and that's going to be so close, it's pretty easy to extend your line. If this line I figured out was right here, I can extend it straight another foot based off of how long that is. And so that's a way you can check without having to figure out these squares and square roots of these hard stuff. You can just get close, check those numbers for square, and then you'll get rolling. So I hope that makes sense.